The ratio test, if the limit as n goes to infinity of your a sub n plus 1 term over a sub n term is equal to L, a finite number less than 1, then your infinite series is absolutely convergent, which means it's convergent. Property 2, if the limit as n goes to infinity of your a sub n plus 1 term over a sub n is greater than 1 or infinite, then your infinite series is divergent. If the value comes out exactly 1, the ratio test is inconclusive. First example, the sum from 1 to infinity of negative 1 to the n times n cubed over 3 to the n. Your a sub n plus 1, you replace all the n's with an n plus 1. Negative 1 to the n plus 1, n plus 1 cubed, 3 to the n plus 1. The a sub n that's in your denominator is just take what you see and recopy it. We're going to take the limit as n goes to infinity by taking absolute value, and that's what you do in all the cases. You eliminate your alternating sign terms. So that gets us down to n plus 1 cubed over 3 to the n plus 1 all over n cubed over 3 to the n. Since this is a complex fraction, we have limit as n goes to infinity of n plus 1 cubed over 3 to the n plus 1 times the denominator flipped, 3 to the n over n cubed. We can pull out a 1/3 because this is 3 to the n times 3 to the 1. We can pull that 1/3 out. We get an immediate cancellation of the 3 to the n's, leaving us 1/3 limit as n goes to infinity of n plus 1 cubed over n cubed. This limit is equal to 1 because the dominant terms are n cubed top and bottom, and their lead coefficients are both 1. 1/3 times 1 is equal to 1/3. That's less than 1, so property 1 in the theorem is met. That tells us that our series is absolutely convergent. A second example, let's take the sum from 1 to infinity of 2 over n factorial. No alternating signs here, but let's go ahead and build our terms. Replace both n's with an n plus 1, 2 to the n plus 1 over n plus 1 factorial, all over, then you just take a copy of what your original problem is and put that in the denominator. Complex fractions, so we have the limit of the top fraction times the bottom fraction flipped over. 2 to the n times 2 to the first. Those 2 to the n's will cancel. Remember that n plus 1 factorial is, let me pull up my marker here, the same as n plus 1 times n factorial. Well, those are going to cancel, and so these 2 to the n's will also cancel, leaving us with a 2 and an n plus 1. What's the limit as n goes to infinity of 2 over n plus 1? That's equal to 0. That's less than 1. Therefore, our infinite series converges. With a root test, it's fairly similar as far as the outcomes go. You're going to look at what your limit value is, whether it's less than 1, greater than 1, or infinity, or equals 1 is inclusive. It's the setup that's a little different. You're going to actually take the limit as n goes to infinity, the nth root of the absolute value of the term in the problem that you'll be given. The sum from 1 to infinity, and it's easier to recognize because you'll have an exterior power of n or 3n, 5n, something to that effect. And a lot of times the problems in your homework will just flat out tell you to use the root test. But anyway, here's how we set that up. This is your a sub n. 2n plus 3 over 3n plus 1 all to the n power. The setup for the root test is always the same. It's the limit as n goes to infinity. You'll take the nth root of the absolute value of the original term you're given to the nth power. Nth root of n power cancels, giving you what's underneath. The limit as n goes to infinity of 2n plus 3 over 3n plus 1. You look at your dominant terms. Both are n to the first, so that's 2/3. That's a limit less than 1. Therefore, your series is absolutely convergent, meaning it converges all the way. Another example, the sum from 1 to infinity, negative 2n over n plus 1 all to the 5n power. So this term is your a sub n term. Let's apply the root test. Limit as n goes to infinity, the nth root of the absolute value of negative 2n over n plus 1 all to the 5n. That nth root and that power of n will cancel. This 5 survives, so that's going to be 2 to the 5th, n to the 5th, because they're a product. Now the negative goes away due to the absolute value. So 2 to the remaining 5th, n to the 5th, n plus 1 quantity to the 5th. 2 to the 5th is 32. The limit as n goes to infinity of n to the 5th over n plus 1 to the 5th. If you were to expand that 5 times and multiply, your most dominant term would be n to the 5th. So this has a limit of 1. That 32 out here times the limit of 1 is equal to 32. Well, that value is greater than 1, so your series is divergent. This diverges by the root test. It's pretty easy to set them up. You just have to be careful in here when you cancel your root and power, and then just correctly evaluate your limit. If your answer is less than 1, great. Greater than 1, that's okay too. It just means that your series is divergent. And if you happen to get a straight up 1, the root test is inconclusive. Let me know if you have any questions or concerns. Reach out by email or phone, ask in class, or come by the office, and I'll do my best to help you out.